My name is Rana Marastam, and I will teach you this course titled Meteorology and Climate Change. So, this is actually a 3 credit hours course, Meteorology and Climate Change. This is actually a 3 credit hour course. So, 3 credit hours mean we will have 2 credit hours for the theory part and 1 credit hour for practical. So there will be 2 theory classes and 1 practical class. However, unlike theory part, the practical 1 credit hour of practical means 3 credit hours of theory. It means that in total we will have 2 classes for theory part, means that we will have 100 minutes for the theory part and 150 minutes for the practical part in 1 week. So this is actually the marks distribution. So I have divided the total 60 marks into 4 segments. That 12 marks will be covered in the mid part, and there will be sessional marks that will include 4 quiz and 4 assignments. And it means that 2 quiz will be and 2 assignments will be conducted before mid, and rest of the quiz and assignments after the exam. So I have allocated 8 marks for these quiz and assignments. Rest of the marks are divided equally among final and practical marks. Right. So these are the course contents that we will cover, and the highlighted contents, the contents that are highlighted in red color are I have updated. These are the new contents that were not the part of this course before earlier, right? So in theory part we will cover some of the fundamentals related to the weather, meteorology, weather, climate change, and climate system, right? And we will also see some of the factors that affect the weather and climate systems. And then next one we will study the equipments that are being used in meteorology, right? And in the practical part, we will determine some of the very important parameters of weather and climate. So these you all already aware of these parameters. So these include pressure, temperature, humidity, and precipitation, and there are some others. While the updated contents include the acquisition of climate data because there are certain you can have 2 types of climate data or weather data. The one is the primary source, which is observed data, but there are certain areas or some areas where you can't find observed data, and there are some other there can be some other challenges, right? Like you cannot have access to, even there is observed data that is available, but you can't have access to those data sets. In that case, you can go for alternative data sets. And there are some international institutions who offer, climate data sets for that cover the whole globe. And these sources include satellites and some reanalysis data set or interpolated data sets are also available. So we will have tutorial sessions and we will learn that how to get those data sets in case if you don't have observed data, right? So these are the contents that we will cover. And since we are actually following the OBE system, outcome-based education system. So outcome-based education system is based on the outcomes. So there are CLOs, I mean the course learning outcomes, that are specific to, there are 4 CLOs, and each course actually can have up to maximum 4 CLOs and minimum 1 CLO. And there are 12 program learning outcomes, and likewise, uh, each course must have minimum 1 PLO or must achieve minimum 1 PLO and maximum 4 PLOs, right? And then there are some taxonomy levels that start from basic knowledge to application, and as we are covering the middle level taxonomy levels. These are comprehension and analysis. So I hope that once you finish this course, so you will be able to understand the fundamental principles, concepts, and applications of metrology, metrological equipment, and you will also be able to understand the fundamentals of climate change, and climate data sources, and their application as well. So this covers the first CLO, course learning outcome, and the CLO comes under PLO1, the engineering knowledge. And so the second CLO is you will also be able to analyze data on weather and climate parameters. Since the metrology is a field like in which you can have the equipment or instruments, but you will not have the chance to use those equipment because the instruments or equipments are already there. They are already installed. What you have to do is, in practical part, you need to visit the observatory, and you will record the readings of weather parameters, say the temperature, precipitation levels. So, and after getting those data sets, you can analyze to find out various characteristics of the weather as well as the climate, and the impact of effect of other factors like sunlight and human intervention on the weather and the climate. So that's why I have written here to analyze data on weather and climate parameters. So since the practical work involve field visits, and some of the tasks or practicals you will perform individually, and some of those will involve teamwork, right? So that's why the second PLR is individual and teamwork, and it covers the domain of psychomotor. Psychomotor means it involves hands-on training or practice, or you will be able to use the learned skills, and you can apply those skills, right? So this involves handwork, and the first CLO or PLO involves cognitive or knowledge domain, right? So these are the two CLOs and PLOs you will achieve through this course. There are actually, I have told you, there are 12 PLOs, and the highlighted PLOs are those that we will cover in this course: engineering knowledge and individual teamwork. Engineering knowledge means once you will go through this course, you will have the classes, you will study, and so you will get the knowledge, right? So so the first PLO wants you to develop the ability to apply or to use that knowledge. I mean the knowledge of mathematics, I mean the calculations, because there will be some tutorial sessions that will involve some kind of calculations, and also we will have some numerical problems. So by solving those numerical problems, you will be able to learn the ability that how you will the knowledge that you will learn through understanding the fundamentals. You can use that knowledge, right, to solve the complex engineering problems. So, and the second PLO that outcome-based education system wants you to achieve through this course is through performing the practicals individually or in a team or as a part of a team. So you will be able to you will be able to develop the ability to work effectively as an individual or as a part of a team, right? Or you will be able to use the gathered data and to analyze it for getting some useful information. These are the suggested readings, and you can download these 4 books by yourself, or if any one of you faces any problem, so you can contact me, or else you are not bound to these 4 books. So the contents we will cover in this course. If you find any information relevant to these contents, so you can read any book or any literature or any research paper. You are not bound to these 4 books, okay? Or if you find any authentic or more reliable or cutting edge book or knowledge other than these 4 books, you can also share with me. So this is actually the outline of today's lecture, that we will cover some of the fundamentals regarding this course, meteorology and climate change. Then we will see the climate, what is a climate system and what are its components, and how they interact with each other, right? So it is important to know the climate systems. So why is it important? So we will talk about it in the coming slides. Let's see first some of the fundamentals. The first and the most important terminology is the weather. So when it comes to know about the meteorology and climate or climate change, so the first thing that you will have to learn is the weather, right? So weather actually is the collection of information, or weather is the information on these 5 parameters. There are actually 27 parameters, but these are the most important parameters, to include temperature, precipitation, humidity, wind, and wind direction, and speed, and cloud color, cover, and time. So if you measure the values or these 5 parameters for a shorter period of time, for a specific period of time, say 1 day, 1 hour, or 1 week, so and for a specific location, say Faisalabad or University of Agriculture Faisalabad, so those values for these parameters will be termed as weather, right? And so here the 2 things are very important: time and location. So if you have a shorter time or specific time, or if you have a specific location, so then if you are asked to measure the values, or to note or to record the values of these 5 parameters, including temperature, precipitation, humidity, wind direction, speed, and cloud color, and cloud type. So those values for that particular time and for that particular specific location will be termed as weather, right? So to make it more clear upon you, so this figure actually elucidates the concept of weather. So here I have told you that there are 3 things. One is parameters, this temperature, precipitation, wind, and 2 others, right? And the next one is the location. So here I have captured this figure for a location, that is check number 48-3R, right? And for a specific time, and so this one is the location, and the second one is the specific time. So this is Monday, right? We are talking about a specific day, which is Monday, and we have recorded their values. That is temperature is 27 degrees Celsius, and precipitation for that specific day or on that particular day was 0%. Humidity was 46%, and wind speed was 13 kilometers per hour. So this is actually the weather information for a particular area, that is known as 48-3R on Monday, right? So this is called weather. So this information, the 5 parameters and the 27 others, 22 others. So that will make the weather of this specific location, right? I hope you understood. So if you have any question, you can write to me directly, or you can write in the group. Simplify. So the next term is climate, that is very closely linked to the terminology weather, right? Uh, Weather, as we have told you, weather actually two things that actually differentiate between weather and climate. So this is actually time, right? So weather is to measure temperature, precipitation, relative humidity, and other parameters for a specific area and for a particular time. Particular time is for a shorter period of time, say 1 hour, 1 day, 1 week, or 1 month, or say 1 year. So that is actually the weather. But if you increase the time span, say 10 years, 20 years, 30 years, 40 years, and you calculate one average value for temperature, precipitation, um, and other parameters, so that is called climate. That's why climate is defined as a weather averaged over a long period of time, right? And since climate also involves the same parameters that weather involves. I mean, climate is also calculated based on the temperature, precipitation, rainfall, relative humidity, but it involves a longer span, right? And that span is actually at minimum, it's considered at 30 years, right? Or since the climate is calculated, involves some calculations, that's why climate encompasses the statistics of, or you can say the calculations of temperature, humidity, atmospheric pressure, and the other parameters, right? And the minimum or the recommended or the standard period for to declare the climate, to decide or to define the climate for an area is 30 years, and this 30 years period is defined by the WMO, World Meteorological Organization. But this is not the final final time period. Condition may change, availability of data may change, or some other factors may involve. So that will make you to change this time period from 30 years to 20 years, or 10 years, or 40, or at maximum 30 years period is recommended, or at minimum, if you have if you do not have any problem, if you do not have any constraint, I mean data constraint or any other constraint, so 30 years period is the minimum. But if you have the constraints, then the 30 years period is the maximum limit. So actually, this figure shows the, the global wide classification of different regions based on their climate. And there are actually 14 climate regions. So actually these regions have been defined based on the average temperature, precipitation, relative humidity, rainfall, and sun hours values for a minimum of 30 years, right? So there are 14 regions that vary from tropical wet to the non-permanent ice region, right? And if you want to have insights, further insights into these climate regions, so you can follow this link. You can just click on this link, and you can find further information on these climate-based classifications of the whole globe. So the next is after knowing about weather and climate, so the next term is meteorology. Meteorology actually is the measurement. Meteorology involves the use of meteorology is the science of you can say the atmosphere, right? Or it is an atmospheric science which makes use of instruments to measure weather parameters or climate parameters, right? I think the weather is more appropriate if you use the word weather. So, the second thing, first one is the use of instruments to measure or to record weather parameters. The second thing is that it involves forecast. So there are two things, recording and forecasting. So these are the two prime roles of or major roles of meteorology. So if you talk about the domain, so meteorology actually basically covers atmosphere, right? And uh, meteorology. So this is a more comprehensive definition. If you want to study, you can do it by yourself. But I have explained to you that meteorology covers three aspects. It is a science of, or it is atmospheric science, which involves recording of or weather parameters, and it also involves forecasting of those parameters, not for a longer period, not for a shorter period of time, say for 1 week, for 2 weeks, for 1 month, at maximum for 1 month, right? So this is actually the meteorology, and we will see this term meteorology in a more greater detail in the coming lecture. So now, before going into further detail on meteorology and climate change, so let's try to understand at first what is actually the climate system. So our climate system is a very complex system, right? And it is highly interactive, and it comprises of 5 components. So these 5 components I have enlisted here. One is atmosphere, biosphere, cryosphere, hydrosphere, and lithosphere. So actually, these components are not only independently work in themselves, but they also interact with each other. So, but there are some external forcings or influencers who actually, you can say, drive these 5 components of climate system. So one of the external forcing is sun, right? Because the solar energy is the prime driver of for these 5 components of the climate system, and the second one is the human intervention. So human activities also affect the normal working of and the interaction of these 5 components. So this figure actually shows the schematic of a climate system. Actually, if you see from right, from top, this part, the blue part actually shows atmosphere, and it involves various things like you can see in detail here. Or the second one is hydrosphere, biosphere. So they not only work independently, but they interact with each other. And for what purpose? For sustenance of life on this planet, right? So now let's see these 5 components of the climate system in more detail. So let's see what is the atmosphere. So you know that atmosphere is a gaseous, component of climate system, of the climate system. And if you see its composition, so it comprises of various gases. So nitrogen is a major constituent, and oxygen is the second one, and the rest of and both of these comprises 99% or more than 99% of the atmosphere, while the rest of the 1% or less than 1% are other gases like carbon dioxide. So carbon dioxide is more prominent out of those. The water vapors are there, dust particles are there, and xenon and neon, these gases are also the part of this 1%, right? So this atmosphere, we can divide this atmosphere into 5 layers, and this classification is mainly based on the temperature variations, because from the ground surface to upward temperature varies, and there are some regions. If we move up from the ground surface, there are some region where temperature sustains to a specific value, and there are some regions where temperature gets lower and lower, and there are some regions where it reaches to very high values. So based on those temperature variations, so the atmosphere has been divided into 5 layers. So if you see this figure, especially the one on the right side, the horizontal axis shows temperature variations in Fahrenheit, and on top it is the same is represented in degrees Celsius. While the vertical axis shows on left it is in kilometer height, and on right side the height is represented in miles. And you see the total atmosphere has been divided into these layers. One is the troposphere, stratosphere, hydrosphere, mesosphere, and thermosphere, right? And this magenta color actually shows the ozone layer that actually protects us from ultraviolet radiations. And the figure on the left side shows the applications or uses of each layer for different purposes, and this text actually explains their characteristics, while this figure, this vertical figure, shows their various applications, right? Or various natural or anthropogenic activities that actually take place in each layer. So let's see these layers in bit more detail. So the first one is the troposphere. So this troposphere is that layer in which actually we live, and this layer actually starts from the ground surface, and its height varies from 7 kilometers upward to 1700 kilometers at the equator. Uh, this variation in its thickness is due to the local weather conditions in each area, because weather conditions in poles or at poles are much more different than the equator, right? So due to these weather conditions, local weather conditions of each region, so the thickness of troposphere actually varies. And, most of living beings, actually, we, the humans and animals and the plants, so the life actually resides in the troposphere. The second one is the stratosphere. Stratosphere starts where troposphere ends. So, troposphere extends from 7 kilometer to 17 kilometer to above 51 kilometers. And there is one layer between troposphere and stratosphere that is called tropopause, that separates troposphere from stratosphere. So if you see in the previous figure, I have missed one thing, that this magenta line. So this shows temperature variations. If you see, if it moves towards left, if it inclines toward left, it means that there will be a decrease in temperature, and if it rises up vertically, it means that the temperature sustains. However, if it inclines towards right, it means that there will be a rise in temperature, right? And if you see the troposphere, the temperature actually is highest at the ground surface, while it starts decreasing as we move upward up to its up to the tropopause. Here it gets to a minimum value of, say, minus 42 or 43 degrees Celsius, right? While in stratosphere, temperature starts increasing and it reaches increasing, and it reaches to a value of say 1 or 2 degrees Celsius compared to the point where actually stratospheres start, or compared to the point to the troposphere, tropopause, where it decreases to a minus 43 degrees Celsius, right? And let's next layer is the mesosphere, and the mesosphere extends from Hydrosphere, and it extends from stratopause. Stratopause is a layer that separates the mesosphere from stratosphere, and it extends further 80 kilometers from the mesosphere, from stratosphere, right? In this layer, actually, most of the meteors burn when they enter into the atmosphere, and temperature decreases with the height in the mesosphere. So temperature is normally high in mesosphere, and then it's start here, and it decreases to minus 80 degrees Celsius, right? From 0 to minus 80 degrees Celsius. And then the last, the second last is a thermosphere. Thermosphere, it further extends from mesosphere, and this is the layer where temperature is very high, nearly 1500 degrees Celsius temperature increase. But there is one difference. Uh, Unlike other layers, other 3 layers, in this layer, the air molecules or gas molecules are apart, are at a larger distance, right? It means that larger the distance between molecules, so, so more difficult is to measure the temperature, right? However, the overall or the average temperature is near to 1500 degrees Celsius, very high. So the last layer is exosphere. This is the outermost layer of Earth's atmosphere, or so it further extends from thermosphere to upward, and it has no limits, right? And maybe it extends to some 6,000 kilometers. So here the density is very low, that such that it is very low, and the particles are very far apart from each other, and that they can travel hundreds of kilometers without without any collision. Uh, since the density is very low and the particles are very apart from each other, so the gases actually, or the atmosphere, does not behave like a fluid, right? So in this exosphere. So the next sphere is hydrosphere. Hydro means water, or it includes or covers all the liquid water components that is present on this earth, or it includes both fresh and saline water. Of course, the saline water is the major component, or the dominant part. It includes oceans, seas, and saline lakes, and also and the fresh water is a fractional part of the total water available on this earth. It includes freshwater lakes, ponds, rivers, and streams. So you know that of the whole globe, hydrosphere covers 70%, right? And 30% are the land masses of lithosphere. And it is the hydrosphere also is a house, serve as a home to many living beings. And if you see the water budget, so you can see this figure from left, the blue part actually shows ocean. So this is saline water, and the 2.8% is green or fresh water. Out of these, the major portion is covered in ice sheet, and second major is groundwater, and the only 0.02% is the water that is available. This is flowing water, you can say, it is fresh and flowing water. And you can see the further classification, right? So this is actually the overall water budget, and this covers the hydrosphere. The next one is the lithosphere, or you can say the land sphere or soil sphere. It contains soil, rocks, mountains, and right. So and the fossil fuels that are present in the lithosphere beneath the soil surface. So if you see this figure, so the one at the top blue part shows the earth crust, right? And as you go down, uh, so there is a mantle, and temperature also varies or normally increases from uh, ambient temperature at the surface to to nearly 2000 or more degrees Celsius at Earth's center. However, Earth crust and upper depth of say 100 up to 100 kilometer, it is a part of this lithosphere, right? And the cryosphere is also another comprehensive component of our climate system. And cryosphere actually is the frozen water, right? And it is available in different formats like snow, solid precipitation, permafrost, ice sheets, ice caps, glaciers, and sea, river, and lakes ice, right? So if you see these all formats one by one, so first one is the snow cover, which is the second largest component of cryosphere, right? And it covers nearly 47 billion square kilometer area around the globe, and most of the Earth is snow covered, and it is located in the at poles, northern hemisphere and the southern hemisphere. I mean, Antarctica and Arctic. On the other hand, it is not only the biggest storage or component of cryosphere, but also provides the storage of fresh water, right? Especially because you can divide snow cover into two: the one which is permanent and the other one which is seasonal. Especially the one which is seasonal and which accumulate or form for a certain period of time when temperature drops to a certain to negative values, and then it melts during summer. So that actually melted ice contributes to freshwater bodies like lakes, rivers, streams, etc. And also it is this seasonal snow, when it melts, it also contributes to groundwater reservoirs. Actually, groundwater can further be divided into two components. One is the deep groundwater, that is the older groundwater, and the shallow water is the fresh water, the fresh groundwater, or in terms of age. So this ice, this snow cover, when it melts, it contributes to the shallow groundwater, and the sum of its part actually also contribute to deep groundwater resources. So as an example, you can see that more than 80% of annual runoff in Colorado River, it comes from snowmelt. The next one is sea ice. So sea ice, mostly you can find sea ice in polar regions. I mean, northern and southern hemispheres or poles, in Arctic and Greenland and Antarctica regions. However, satellite-based studies reveal that the cryosphere is also a dynamic system as sea ice changes with time or with the changes in temperature, or we can say changes in seasons bring changes in cryosphere and makes the cryosphere a dynamic system, right? Or the second type of ice is ice that forms on the freshwater bodies like rivers and lakes. And this ice is totally almost the major part of this ice is seasonal ice, right? However, unlike sea ice that has a major contribution or influence on global climate, so the local ice form, since these water bodies are very small, and if you recall the water budget that I have presented in the previous slide, water budget in the hydrosphere part. So you can see that the fresh water or flowing water is is a fractional part of the total water, fresh water, available fresh water, right? So it means that this ice, though seasonal, but have very small influence on the climate. Rather, it influences the local climate. However, contrarily, the local or the global scale parameters, they affect the accumulation of this ice or formation of this ice, or they also affect its formation. They also affect its time of accumulation and the duration of accumulation and melting rates and accumulation rates, right? So the next one component of cryosphere is the frozen ground. So this is also one of the largest component of cryosphere. Frozen ground means permafrost. So actually, when water penetrates or percolates or infiltrates into the soil, in an area where temperature is very low, say between -1 to -7 degrees Celsius, the average annual temperature, so that water actually melts. That water actually starts freezing in the soil. So that soil plus frozen water, this is known as permafrost. So it can be seasonal or perennial, and it covers an area of 54 square kilometers. And mm, so major part of this permafrost or frozen ground lies uh, in the in the Arctic and Antarctica, or in polar regions, and also you can also find frozen ground or permafrost in glaciated regions like Himalayan region in subcontinent, right? Or so permafrost can be seasonal if the temperature, average annual temperature lies between that is between -1 to -2 degrees Celsius, and however it will be continuous if the average annual temperature lies below -7 degrees Celsius, right? Okay, so the next one is ice sheets. So there are two ice. One is ice that forms on water bodies, right? And the second ice is that accumulates in the form of sheets on the ground, right? On the ground surface, on land masses. So ice sheets and glaciers are flowing ice masses. So and actually, there is a difference between ice sheets and glaciers. So glaciers are, you can say, the permanent accumulation of these are the reservoirs, ice, or you can say these are the snow reservoirs that are permanent. Though some of the snow melts, but they are permanent if there is not any change in the external influence forces. If there is an external influence, so they can also get melted. Their melting rate can increase, can exacerbate, and resultantly glacier also start to squeeze. And I will also try to give you some idea that how this phenomenon actually works in the coming slides, in the coming lectures. However, ice sheets is the temporary ice layers that actually accumulate and melt based on the season of the year or temperature values. Okay, so ice sheets are the greatest potential source of global fresh water, and they actually hold approximately 77% of global water. And if you measure their the quantity of water in terms of equivalent of water height, so all the ice sheets that stores fresh water, so they are they equals to 80 meters of height of water, right? And the major part of these ice sheets actually is you can find in Antarctica and Greenland, and the rest of the fraction is available in glaciers in different regions, right? And Himalayan regions are glaciers are one of those. This figure actually shows globally scale distribution of cryosphere in its different formats: snow, ice, sea ice cells, ice sheets, glacier, ice caps, permafrost, right? And you can see most of the ice is or the cryosphere actually lies in the poles. So this is actually Antarctica Antarctican region, and this one is the Arctic region and Greenland. So the next one is biosphere. Biosphere actually involves living beings. They can be humans, animals, plants, microorganisms. So life, life to make the life sustainable, or to make some living beings to be able to live in this on this earth. So we need energy, we need food, right? We need these two basic entities. So to make these things available, actually biosphere interacts or depends on other spheres, and it interacts with other spheres like lithosphere, atmosphere, and hydrosphere, and makes it possible or make this earth livable for us and provide food and energy for our need. So it also not all only includes the living organisms or beings, but also includes their dead organic matter produced by them. So you know that to live on this earth, there are two basic needs. One is energy, and the second one is the food. So now, how does biosphere interact with other spheres? For example, if we talk about ourselves, the humans, we inhale, we need oxygen from here, right? And oxygen is present in the atmosphere, right? So we get this oxygen, and we take this oxygen into our bodies during inhalation and use it to make energy in our body, right? And the other one, so in that case, the biosphere actually interacts with the atmosphere, and biosphere also interacts with the cryosphere, with the lithosphere, and with the soil. Let's take the example of crops. Crops need water, so in that case, they get water from from hydrosphere, the water available in freshwater bodies or flowing water, and they also need carbon dioxide and oxygen, and they get these two gases during the process of photosynthesis, right? So in that case, biosphere interacts with the atmosphere. And the third one is plant gets nutrients from the soil. they get nitrogen from the soil, and in that case, plant actually or the biosphere interacts with lithosphere, right? Another example we can take is of microorganisms. You know, there are several microorganisms that are present in the soil, and there are bacteria, and these can be nitrifying bacteria or nitrogen fixation bacteria that transform nitrogen from one form to other form that is more usable by the plants. So in that case, biosphere again interacts with not only with the atmosphere but also with the lithosphere. This figure actually shows global wide distribution of the biosphere. It can be plants, it can be humans, or it can be any living things, right? Now, I have told you that these systems or the components of climate system, not only they work independently, but they also interact with each other. So, and their interaction is actually controlled by some external forces or some external forces. So one of those is sun, because sunlight or energy is the basic entity or the requirement for any uh, uh, component to work. For example, if we talk about hydrosphere, so you might have heard about water cycle. You know, water cycle, the basic requirement for and water cycle is or hydrology cycle is a continuous process, and energy or the heat is a basic requirement, because water it starts from evaporation. Evaporation requires energy, and this water then again condenses, uh, and then it starts downpour on the starts coming down on the earth depending on the local temperature, right? So that's how these actually interact, or the components of the climate system actually depend on energy. And the second one is the humans. Humans also act as the external influencer for the climate system, and they can influence their normal work. For example, you know, atmosphere has its defined composition. If in its pure form, it has a nitrogen 78%, oxygen 41%, and carbon dioxide like 0.003%. However, the human activities like burning of fossil fuels, it contributes more towards these activities actually emit carbon dioxide and increase its concentration. On the other hand, what happens? The plants, which are the major users of carbon dioxide, due to forestation, the amount of carbon dioxide actually increases in the atmosphere, right? And this increase in carbon dioxide acts as a trap for the incident energy that is coming from the sun, and resultantly the phenomena of global warming actually starts. So that's how the humans are the second important or significant influencer on the climate system and its components. Let's see their interaction. I have already explained you their interaction, but let's see in a bit more detail. So the first interaction is between atmosphere and hydrosphere, right? And you know, the oceans and atmosphere store energy. They exchange energy, right? And in the form of heat, moisture, and momentum. You know heat and moisture, right? Water evaporates, and then it travels uh, through the atmosphere, right? So atmosphere not only interacts with the hydrosphere by exchanging heat, but it also acts as a carrier for the evaporated water, right? And the second one is the momentum. Momentum means continuous working of, since the water cycle is a continuous process, right? And this is actually called a momentum. So continuous process to make this water cycle run at its standard rate, right? Standard natural rate. So that is the momentum. Second one is that air is also the part of atmosphere, right? Or you can alternatively say that air is actually the atmosphere, because what I have explained you about atmospheric composition is actually the composition of air. So you can check on the internet that what is the composition of air. So you will find the same figures, like 78% uh, nitrogen, 21% oxygen, and 1% rest of the trace gases or particles, right? Or moisture content. So the air is, there are tides and waves in the oceans. So this is due to air or wind, flowing air, the winds. So this is the second, another way by which atmosphere and hydrosphere interacts with each other, right? Through a water cycle, through exchange of heat, and by making or by keeping ocean water circulating, right? This is also three, I have given you three examples that how atmosphere and hydrosphere interact with each other. The other way is that oceans can absorb more heat. How? And their rate of releasing the heat is much more less than the land surface, right? And this difference in heat exchange rate of heat exchange also affect local as well as global climate, right? The next is how atmosphere actually interacts with lithosphere. If 100% energy comes towards Earth, or if 100% of energy is received at upper layer of the atmosphere, so 50% of that energy is actually absorbed into the land, absorbed by the land. And when it is refracted back to the atmosphere, so this energy actually uh, its wavelength actually changes and its energy value actually increases, right? So the atmospheric absorption of this long wave terrestrial radiation primarily by water vapor and carbon dioxide is responsible for heating the atmosphere. So it means that the energy required by the atmosphere that is being used for other spheres is provided by the lithosphere, right? And this is how atmosphere and lithosphere actually interacts with each other. And another is the interaction between the atmosphere and biosphere. I have told you, if we talk about humans, so we are the source of interaction between the atmosphere and the biosphere. We are the biosphere, we are the component of the biosphere, and we inhale air, so that is an interaction, right, between atmosphere and biosphere. And plants, that's photosynthesis process. Plants are the biosphere, are the component or part of biosphere. They interact with the atmosphere through the photosynthesis process. And the biosphere also affects the input of water in the atmosphere through evapotranspiration. And atmosphere's radiative balance through the amount of sunlight reflected back to the sky. Uh, so this is another way how atmosphere and biosphere actually interact with each other. Next is interaction between atmosphere and cryosphere. So sea ice hinders the exchange between atmosphere and oceans. So let's see another example. For that we need to go one step behind. one step back. That is the formation of ice, sea ice, or the formation of ice on freshwater bodies, or the formation of snow, right? So is also another interaction between atmosphere and cryosphere. So normally the sea surface actually interacts with, there is a direct contact between air and the sea surface, right? And this contact actually not only exchanges the heat content but also controls the temperature of sea surface. And with the change in season, when winter starts, the temperature of atmosphere actually starts decreasing to freezing point. And since ocean surface uh, interacts with that air or freezing air, so resultantly the top surface of sea actually starts freezing, right? So the formation of ice sheet in itself is an interaction. The result of is it itself is the result of interaction between atmosphere and the biosphere, right? Then after its formation or creation, it hinders the other interactions, right? And uh, temperature actually, the amount of heat that transfers from atmosphere to the oceans, actually the formation of ice affects the amount of heat exchange between atmosphere and cryosphere. So this is how I have given you two examples that how atmosphere and cryosphere actually interacts with each other. The next one is interaction among all sphere. We see in a commutative way. So for that, we can take the example of plants. And plants is the best example to describe. I have explained you this example in previous slides, but let me repeat it again. So plant, you sow it, it grows, and during this life cycle, uh, plants get their energy through, or produce their energy. They need sunlight, and they need gases like carbon dioxide and oxygen. Carbon dioxide during the day and oxygen during night time. So this is actually the interaction. Exchange of these gases during photosynthesis is the interaction between biosphere and atmosphere. So plants use water, and this water is coming from the freshwater bodies, right? So that's how, in that way, the plants or biosphere interact with hydrosphere, and they get nutrients from soil. So there is an exchange of nutrients between plants and soil, and or alternatively, you can say that there is an exchange of nutrients between lithosphere and biosphere, right? So this is how these. This is a very comprehensive, good example. I hope that you understood the concept of interaction of these spheres, right? And let's see what has been written here. The abundance of greenhouse gases in the atmosphere is controlled by biogeochemical cycles that continually move these components between ocean, land, life, and atmospheric survival. I mean, the exchange of gases, because gases are required for in all spheres, whether it is lithosphere, is it or is it hydrosphere, biosphere, or atmosphere. So gases are these are not only one component that are you can say the shared among or that are actually required by others all or used by all spheres, but there are also some other components. But to make you understand, uh, this concept of interactions. So greenhouse gases are just considered or taken as an example, right? So the use of greenhouse gases in all spheres is an example of interaction of all spheres, right? The second one is that the abundance of carbon in the atmosphere is reduced through seafloor accumulation of marine sediments. Okay, and since there is a direct contact between sea surface and the air, so when the air comes in contact, it not only exchanges carbon but also exchanges oxygen and carbon dioxide, right? And accumulation of plant biomass and is increased through deforestation and burning of fossils as well as through other processes, right? So burning of fossil fuels or burning of or deforestation or burning of forest, and as a result release of gases is another type of interaction between biosphere and atmosphere, and these gases are absorbed into the oceans. So again there is an interaction between biosphere, hydrosphere and biosphere. So that's how they interact in a cumulative way. So thank you very much. So this was your first lecture. So the next lecture we will see the science of metrology and its principles and its fields and instruments and some basic information of fundamentals in the next coming lecture. So thank you very much. So if you have any questions, please write it to me personally or you can write it in the group. Assalamu alaikum.